This section is called FOIL method and special products. So I'm assuming we got to expand some factored forms and all that. So let's see what this is about. Okay, number one, which is following is equivalent to the expression shown above. Okay, so this looks like it can be very time consuming if you expand this out and expand all these out. You probably don't want to do that. So let's think of a little smarter method. This doesn't even have to involve FOIL. This probably involves what they call special products, or if this sounds familiar, the zero product problem. This might help you, actually. Okay, so let's assume this is equal to 0. So what values of x would make this true? It would be x is 5 and x is negative 3. Hopefully you see that. Because when x is 5, this would be 0. 0 times who cares is 0. When x is negative 3, this would be 0. 0 times who cares is 0. That's the zero product property. Okay, so let's try plugging in 5 or negative 3 into these. You should get 0 if they're equivalent. Okay, so let's see. If this is 5, let's do this one. That'll be 36 minus 14. That's clearly not 0, right? This is 4. If we plug in 5, right? 4 squared minus 12, that's clearly doesn't work, right? This one might work for 5. That would be 16 minus 16, that's 0. And this would not work because that would be 9 minus 12. Okay, so answer C. We can double check by the other point. Minus 1 minus 3, that's minus 4. Minus 4 squared is 16, so that's 0 as well. So this is how I thought of doing it. Instead of expanding all these out, which will take time, just use a simple trick like this. Okay? Which following is equivalent to the expression shown above. Okay, so we can FOIL this, or you can rewrite this as 2 minus 5x, 2 plus 5x. This should look familiar. This is the difference of 2 squared. So it will be 2 squared minus 5x squared, which is 4 minus 25x squared. And that is B. Okay? You could do that, or you could have done the actual arrows and all that, but this, you should know this formula, difference of 2 squares. You have to know. Okay, which the following is equivalent to the expression above? Well, this is, again, one of the special ones it looks like. It should factor into a perfect square. So it looks like it would be, if we know the formula, it is a minus b squared is a squared minus 2ab plus b squared is the formula. So if we assume it's true, then this one, this a, would be 2x. The b would be 3y. So it should be 2x minus 3y squared. Okay, and we can even double check. 2 times 2x, that's 4x, times 3y, that is 12xy. And then there's a minus because of this minus, so that looks right. So it should be 2x, this one, right? Okay. Which the following is equivalent to the expression shown above. Okay, so let's do these two first. Difference of 2 squares again, that would be x squared minus y squared. And then we have the other term still, the third term. This is again, difference of 2 squares. So it'll be x to the 4th minus y to the 4th. Answer is D. So you gotta know those formulas. Difference of 2 squares, the expansion of a perfect square like a minus b quantity squared or a plus b quantity squared. They're the same formula, technically. The plus or the minus. The difference of 2 squares is a different formula. Okay, what is the value of this guy? Okay, so looks like we got to be a little careful here. Let's use properties of exponents carefully. So when we multiply the 2 on top, we can add the exponent value. So a plus a, that's 2a, 3 to the 2a, minus b plus b, that is 0. Okay, so this would be, you subtract the powers. So it'll be 3 to the minus 1, which is 1/3. Answer is A. Okay, didn't really need FOIL or anything like that there. Okay, this one, let's use the difference of 2 squares formula. 2 to the a squared minus 1 over 2 to the a squared minus 4. Okay, properties of exponents, let's subtract the 2 powers. So it'll be 2 to the minus 1 plus 4, which is 2 cubed, which is 8. That's our answer. Okay, oh, this was a very quick video, 5 minutes-ish. So as you can see, if you know the formulas very well, again, the key ones are, this one was a little different, but the key ones are difference of two squares. When you have a perfect square and you're expanding it, a plus b squared or a minus b squared, that's really the formulas that you really need to know very well by heart. You need this not just for polynomials, but you need it for like complex numbers and all that too, which I think is in a later section. Okay, that's it for this video. Very short and concise. Hopefully you found something helpful out of it. As always, please like and subscribe if you did.